The route to achieving net zero simply must go through chemical engineering. We visited Imperial College London to find out how chemical engineers there are developing holistic solutions to the greatest global challenge of our time.
That gets us most of the way, but we still need to warm up the solution.
This is a carbon capture pilot plant within the Department of Chemical Engineering at Imperial College London. It gives students the opportunity to get hands-on experience in how to tackle one of the biggest challenges of our age, climate change.
So as a chemical engineer, we've got so much scope to be able to work and develop better solutions, more environmental solutions to actually many of the world's problems.
And as you saw on the pilot plant, we're all working together to solve one problem. And I think having loads of people with different backgrounds, people have different ideas and different inputs.
It will actually teach me a lot about just how is it that the carbon capture actually works, and it actually directs and correlates very nicely with just the green energy sector that I'm actually going into, and so I'm really excited to be doing this.
And are you guys part of the same group? You're all working together on the same project?
Yeah.
And working collaboratively will be crucial if today's students are to find solutions for the challenges we all face in the future.
Chemical engineers are uniquely placed to offer solutions to a problem like climate change because of the nature of our training. Our training is in lots of different disciplines so that we can have deep and meaningful and technical, often conversations with people that are from a chemistry background or mathematics or physics or various aspects of engineering and increasingly biology. The other key thing that we can do is to adopt a holistic approach. We can adopt a systems-based approach to look at problems not in isolation, but to ensure that they couple together in an optimal way.
In this lab, they're doing just that by working on ways to take the high content of carbon in waste and lock it into advanced and more sustainable materials such as sodium-ion batteries.
This can only happen when we are sure that the materials that make these technologies, emerging technologies, are also sustainable. So we need to stop using critical metals, and we need to make sure that our resources are locally available for us and also abundant. So we're stimulating a circular economy whereby instead of putting waste in landfills, which generates methane and contributes to global warming, we're taking biomass, we're extracting valuable components from it and using materials. So we manufacture this into very high-end advanced functional materials.
Another research team is looking at how porous materials can filter impurities and pollutants from the air, potentially reducing the energy consumed in the separation process, while at the same time capturing carbon dioxide to be used elsewhere.
If we look at flue gas that we've been emitted by power plant, it can help separate CO2 from nitrogen and other impurities contained in the flue gas. It can also help separating CO2 from air, so from nitrogen and oxygen, so removing CO2 from our atmosphere. And those materials can also help catalyze CO2 conversion into useful chemicals such as fuels, for instance. And working with other scientists and engineers on that specific challenge is really a passion.
I'm very excited about what's possible. We have the possibility to reinvent the way that we produce chemicals of various descriptions and products of various descriptions, to think about different and alternative raw materials, to think about renewable energy. The future cannot be brighter for us, and we can harness all of that for the benefit of humanity so that we can offer workable solutions to the global grand challenge that we're all going to be facing, which is climate change.